Good morning. The homework for today is on page 250, 1 through 59 all, and 63 and 64. Today we're going to be talking about complex numbers. In the early 1600s, a French mathematician proposed that a number be defined to represent the square root of 1. So when he did that, we know that the real number system is made up of natural numbers. Natural numbers are numbers that you count people with or things. Sometimes they're called counting numbers. And then at some point mathematicians added 0, so we have whole numbers because they needed something to represent 0. Then along came integers, which are positive numbers, negative numbers, and 0. 0 is neither positive nor negative. Then at some point they needed something to represent fractions, so along came rational numbers. A rational number is a number that can be expressed as the quotient of two integers. It is a fraction that terminates or repeats. So if it terminates, it would be something like 3/4. If it repeats, of course, it would be like 2/3. So the rational numbers are numbers that can be expressed as the quotient of two integers. Then there were irrational numbers. Irrational numbers are numbers that do not terminate nor repeat. So the best example of an irrational number would be pi. So pi is a good example. The square root of 2 is a good example. The square root of 3. Those are all irrational numbers. Like I said, in the 1600s, a mathematician named Descartes decided that we needed a number to represent the square root of -1. So that's when the complex number system came about. So the complex number system is made up of real numbers. It's made up of complex numbers. We have pure imaginary numbers, which are the square root of a negative number, like -16, which in a complex number system would be 4i. We also have complex numbers, which are made up of a complex number and a real number. So they're represented by a plus bi, so it might be 5 plus the square root of -16, which could be written as 5 plus 4i. So to start with, let's go back to the concepts. So the mathematician said they needed something to represent the square root of -1. So that's why I, an italic I, which is the lowercase I, is used to represent the square root of -1. If you think about the square root of x times the square root of x, you get the square root of x squared, which is equal to x. So if you think about I squared would be equal to the square root of -1 times the square root of -1, which is equal to -1. I cubed is equal to I squared times I, which is -1 times the square root of -1, which is equal to -I. And then I to the fourth would be I squared times I squared, which would be equal to -1 times -1, or +1. So, important part about complex numbers is for you to remember that I is equal to the square root of -1, that I squared is equal to -1, that I cubed is equal to -I, and I to the fourth is equal to 1. So I have some examples. My first example is square root of -4, which you don't have to write this, but this is really the square root of -1 times the square root of 4, which would be I times 2, or we write it as 2I. Nobody's going to write it all out like that. You just remember that if there's a negative number underneath the radical sign and the index is 2, then you're going to get 3I, 8I, and in this case, well, we would simplify this. If we simplify this, we need to rewrite this as the square root of -9 times the square root of 2, and we would get 3I square roots of 2. On the next example, this is -25 times 3x to the 5th. So what would we get? We would get 5I square root of 3, then x squared, and x. We had 5I x squared square root of 3x. So once again, I'll remind you that the square root of x times the square root of x is x. That the square root of -1 is equal to I, that I squared is equal to -1, that I cubed is equal to -I, and that I to the fourth is equal to 1. So like I said, these are all important. You need to remember them, or you need to be able to find them. So my next example, -25 times 2 gives me 5I, then x, and then y, square root of 2y. But we still need to remember our even odd. So we have an absolute value here. Okay, so some of the homework exercises tonight, numbers 5, 6, 24, and 25 are worked like this. You're given an imaginary number out of the 15th, and you're asked to simplify it. I do this a little bit differently than in the textbook because I use the fact that I to the fourth is equal to 1. So if you rewrote this, this would be I to the fourth times I to the fourth times I to the fourth times I to the third. Because if you added up all the exponents, you would get 15. But I to the fourth is equal to 1. So, and then we have I to the third. Well, we know from this information that I to the third is equal to -I. So in simplest form, I to the 15th is equal to -I. We could do the same thing here, but nobody wants to write it all out. So if you divide 4 into 17, it goes 4 times. So you have I to the fourth 4 times. We know that I to the fourth is equal to 1, and the remainder would be what was left over, so we get I to the first. So, like I said, you could write it all out, but that might take a while. Notice here that 4 goes into 24 evenly. So that means that we have I to the 0 would be the remainder. We know that anything to the 0 power is 1. We also know that would be I to the 4th, written down 6 times, so 1 times 1 times 1 times 1. I'll come back to your calculator in a minute. I want to talk about addition and subtraction. In order to add or subtract, it's extremely important that you change your numbers to complex numbers first. So you must change your numbers to complex numbers first before you add or subtract or even multiply or divide. So, the first example that I have up here, I have 5 plus the square root of negative 36. I need to change that to 5 plus 6i, and then 2 minus 2i. So I've rewritten my problem so it is with imaginary numbers. Then what we want to do is add the real parts. This is a real part to this real part. So this is 5 minus 2, or 3. And then we want to combine the imaginary parts. So we want to combine these two. So minus and minus makes it plus, so I get plus 8i. So in simplest form, my problem would be 3 plus 8i. So just like a problem if we had 5 plus 6x plus 3 minus 2x, we would add the parts that are alike and get 8 plus 4x. So that's what we're doing here. We're adding the real parts together, and then we're adding the imaginary parts together to get our answer. Next, I want to talk about multiplication. Once again, it is extremely important that you change your numbers to imaginary or complex numbers before you start. You also need to remember that I is equal to the square root of negative 1, that I squared is equal to negative 1, that I cubed is equal to negative I, and I to the 4th is equal to 1. So if you multiply these together, we get negative 14i squared. Once again, I squared is equal to negative 1. The answer here is 14. On the next problem, I have 3i times negative 4i times 6i squared. So if you multiply these all together, you get 72 out of the 4th. But there's a negative here, so it's negative 72 out of the 4th. The 4th is equal to 1, so negative 72 will be your answer. So like I said, on my next examples, you can't work these problems unless you change them to imaginary numbers first. Otherwise, you're going to get the wrong answer. So in this case, this is negative 9 times 2, and this is the square root of negative 2. So in simplest form, this would be 3i square roots of 2 times I square roots of 2. So 3i times I is 3i squared, and the square root of 2 times the square root of 2 is 2. So I get 6i squared, but I squared is equal to negative 1, so I get negative 6. But like I said, you need to remember to change these to imaginary numbers before you start, or you'll get the wrong answer. On a problem like this, once again, this is I square roots of 10 times, well, this is negative 25 times 3 So this is 5i square root of 3 x and x. We multiply these together, we get 5i squared x times the square root of 30x. We can't simplify 30x, so we leave it like it is, but I squared is equal to what? I squared is equal to -1, so negative 5x square roots of 30x. So like I said, on a problem like this, you would need to change this. This is I square roots of 6 times 2i square roots of 6. So I times I is 2i squared. Square root of 6 times square root of 6 is 6, so I get 12i squared. But I squared is equal to -1, so the answer would be -12. So the next thing I want to talk about is how to multiply binomials. In order to multiply binomials, you need to remember to FOIL. You need to remember that I squared is equal to -1. So I'm multiplying 5 times 3 to get 15. I'm multiplying 5, so I get plus 25i. Then here I'm multiplying these together to get -6i, and I'm multiplying these together to get -10i squared. So I get 15 plus 19i minus 10i squared. But remember, I squared is equal to -1. So this is really 15 plus 19i plus 10. So I get 25 plus 19i. So when you multiply these together, you need to remember, once again, you need to remember to FOIL, and you need to remember that I squared is equal to -1. So my next example, remember you should write this down twice and FOIL it. So I get 9 plus 6i plus 6i plus 4i squared. So here I get 9 plus 12i. Remember that I squared is equal to a negative number, so -1, so I have -4. This is 5 plus 12i. On my next example, you'll notice that it is not in complex form. It needs to be in order to work the problem. So I'm going to rewrite this as 3 minus, well, this is -9 times 2, so this is 3i square roots of 2 plus -4 times 3, so that's 2 plus 2i square roots of 3. So when I FOIL these together, I get 3 times 2 is 6, plus 3 times 2i gives me 6i square roots of 3. And this gives me minus 6i square roots of 2. And then minus times a positive gives me -6i squared square root of 6. So once again, I squared is equal to -1. So this is 6 plus 6i square roots of 3 minus 6i square roots of 2 plus 6 square roots of 6. I can't combine any of these, so that is the answer to the problem. Next, I want to talk about division. Once again, you want to make sure that you have written these as complex numbers. So we're going to rewrite these. This is 5i divided by 3 plus 2i. So just like with radical numbers, you can't have an imaginary number in the denominator. So we want to get rid of it by multiplying by the conjugate. So the conjugate would be 3 minus 2i, 3 minus 2i. So we get 15i minus 10i squared. We FOIL the denominators. We're going to get a squared minus b squared. So we're going to get 9 minus 4i squared. So that gives us 15i plus 10 over 9 plus 4. So we get 15i plus 10 divided by 13. So once again, we need to remember to rewrite our problem so that it is in complex form. We want to multiply by the conjugate. Remember that these are conjugates, a plus b and a minus b, and they always give you a squared minus b squared. We need to remember to FOIL, and we need to remember that I squared is equal to negative 1. So my next example, it is already as a complex number, so we would just multiply by the conjugate. So we're going to multiply by 2 minus 4i, 2 minus 4i. So once again, the denominator is going to give us 4 minus 16i squared, and we get 6i minus 12i squared in the numerator. So that's 6i plus 12, because I squared is equal to negative 1. And it's 4 plus 16, which gives us 20. We get 6i plus 12 divided by 20. Now, because we can divide 2 into each one of these numbers, we're going to make this 10, and this will be 3i plus 6. So in simplest form, it's 3i plus 6 divided by 10. So my next example is a monomial in the denominator. So we're going to multiply by 5i. And when we do, we get 25i squared, and then 20i minus 10i squared. Once again, I squared is equal to negative 1, so we get 20i plus 10 divided by negative 25. Well, I'm okay with you leaving it as a negative 25 in the denominator, but I think your textbook would give you an answer where they would divide a negative 5 into each one of these to get a positive 5 here, negative 4i there, and negative 2 here. Now this takes me to one that's a little bit more complicated. So we're going to multiply by the conjugate, which in this case is 2 plus 4i, 2 plus 4i. The denominator is going to give me a squared minus b squared, so that's 4 minus 16i squared. The numerator, of course, is more complicated. We get 4 plus 8i. Then we get minus 6i square roots of 3, then minus 12i squared square root of 3. In simplest form, this is 4 plus 8i minus 6i square root of 3 plus 12 square roots of 3, all divided by 20. Because I can divide 2 into each one of these, I should. So that would be 10 in the denominator, 2 plus 4i minus 3i square roots of 3 plus 6 square roots of 3. So problems numbers 36 through 41 are work like this. You're given a problem that looks like this. And you're asked to solve for m and n, or a, whatever the variables are. So what you want to do is take the imaginary part and set it equal to the imaginary part, and the real part and set it equal to the real part. So I'm going to set 2m equal to 6, and get m is equal to 3. And I'm going to set 3n plus 1i equal to negative 8i. The i's will cancel and I get 3n plus 1 is equal to negative 8. So 3n is equal to negative 9. So n is equal to negative 3. That's problems numbers 36 through 41. Next, I'd like to talk about the square root property. These are problems numbers 7 and 8, 36 through 41, where you're given an equation and you're asked to solve it. So there's a little property that's really important. It's called the square root property. What it says is if x squared is equal to k, then x is equal to plus or minus the square root of k. Now to solve this, you want to subtract 2 from both sides, and you want to divide by 2 and get x squared is equal to negative 1. Then you want to take the square root of both sides, so it's plus or minus the square root of negative 1. So in this case, x is equal to plus or minus I. Don't forget that I is equal to the square root of negative 1, that I squared is equal to negative 1, that I cubed is equal to negative I, and I to the fourth is equal to 1.
Feeling this edge?
Good morning, Coach. I'm recording this. So you just were put on YouTube. Oops. 2x squared is equal to negative positive 80. So x squared is equal to negative 40. So x is equal to plus or minus the square root of negative 40. So in this case, x would be equal to plus or minus. This is for negative 4 times 10. So we would get 2i square roots of 10. I'm almost finished. So the last topic I wanted to go over is absolute value of complex numbers. The absolute value of a complex number is equal to the square root of a squared plus b squared. So if you had the number 4 plus 3i, absolute value of it, you would just take a would be equal to 5, and b would be equal to 3. So you get 5 squared plus 3 squared, or the square root of 25 plus 9. This is the square root of 34. The absolute value of a complex number is always a real number. So, remember that your homework's on page 250, 1 through 59, all 63 and 64.